Hello, in this video, I will introduce implicit differentiation and I will derive using implicit differentiation. So what is implicit differentiation? Well, obviously, it's just another process of differentiating, but more specifically, it's the process of finding the derivative of a dependent variable in an explicit function by differentiating each term separately, by expressing the derivative of the dependent variable as a symbol, and by solving the resulting expression for the symbol. Basically, you're taking the derivative of each term either in respect to x, time, or etc. So yeah, that's the difference. Um, so why does it look so strange? Well, you're used to explicit form. For example, you're used to y equals 1 over x, right? Implicit form is something like this: y cubed plus y squared minus 5y minus x squared equals -4. Um, so that's why it looks a little bit strange. So basically, you're just taking the derivative of each term in respect to x. And I will show you, these are the steps for implicit differentiation. So step 1 says differentiate both sides of the equation with respect to x or time or whatever they want you to take the derivative in respect to. Collect all terms involving dy dx on the left side of the equation or the right side, as long as you have dy dx on one side, and move all the other terms on the right side of the equation. So basically, when you do implicit differentiation, you might have two dy dx, get all anything to the dy dx terms on one side and anything that doesn't have dy dx on the other side. Step 3, factor dy dx out of the left side of the equation. So yeah, once you have dy dx on one side, factor it out. And then step 4, solve dy dx. So let's do an example. Let's do one example. So let's do example 1. It says find dy dx. So we're going to do implicit differentiation. So dy dx means we are taking the derivative in each term in respect to x. Okay, so let's start with this term, y cubed. What's the derivative of that in respect to x? Well, the derivative of y cubed is actually 3y squared, but because you have to take it in respect to x, because since this is a y, it's going to be dy on the top, and then on the bottom it's dx. Okay, so you just have to add this extra dy dx. That's the kind of like the main difference. And then what about y squared? What's the derivative of y squared in respect to x? So it's going to be plus. Well, the derivative of y squared is just 2y because power rule, right? And then in respect to x, you do have to add this dy dx. And then do the derivative of -5y. The derivative of that is actually -5. And then it's just going to be, in respect to x, it's dy dx. What about -x squared? So this one's a little bit strange. What's the derivative of -x squared? Well, you would just apply power rule. So that would be -2x. But because we have to take it in respect to x and our letter is x, you're going to put a dx on the top, and then on the bottom it's dx. Now, what is dx over dx? It actually cancels. It's actually 1. So you don't have to put dx if you don't want to, because it just comes to 1. And then on the right side, what's the derivative of -4? It's a constant, so it's going to be 0. So what we're going to do is we have a lot of dy dx. We have like 3 terms that has dy dx, right? So you're going to get it on one side, and anything that doesn't have a dy dx, move it on the other side. So the only thing that doesn't have a dy dx is this -2x, right? So move it to the right by adding 2x to the right, to both sides. Okay. So now on the left side of the equation, you have 3y squared dy dx plus 2y dy dx, and then you have minus 5 dy dx equals 2, and then 0 plus 2x is 2x. Okay, so now that we have all dy dx on one side, let's factor out dy dx because they all have that dy dx. So factor it out. And then this is going to be 3y squared plus 2y minus 5 bracket equals to 2x. And then solve for dy dx. So get rid of this 3y squared, 2y minus 5 by dividing both sides by itself. Okay, so this cancels. So your final answer is dy dx is equal to 2x over 3y squared plus 2y minus 5. Okay, so you just found dy dx. Okay, so go ahead and press pause to stop the video and write down all the work. Okay, got it. Let's move on. So example 2 says find dy dx. So okay, let's do these ones. So just like example 1, let's take the derivative of each term in respect to x. So what is the derivative of 4x in respect to x? Well, the derivative of 4x is just 4. And then you do have to add this dx because it in respect to x. So but this just becomes 1. So you really don't have to. So that you don't really have to if you don't have to put that because that just becomes 1. What is the derivative of negative y cubed in respect to x? So the derivative of negative y cubed is negative 3y squared, and then it's going to be dy dx. And then the derivative of 12y is just 12, but in respect to x, it's going to be dy dx. And then on the right side, it's 0, because the derivative of 0 is 0, right? Okay, so looks like we have two terms that has a dy dx. This one and this one, right? And then this fourth is the only one that doesn't have a dy dx, so move it on the other side. So you're going to subtract 4. Subtract 4. So you get negative 3y squared dy dx plus 12 dy dx equals to negative 4. So as you can see on the left side, they both have the dy dx, so take it out. And then this is going to be negative 3y squared plus 12. And then on the right side, it's negative 4. And then solve for dy dx, so get rid of this thing by dividing both sides by negative 3y squared plus 12. Okay, so this cancels, and now you're left with dy dx equals to negative 4 over negative 3y squared plus 12. Okay, so go ahead and pause the video to write down the work. And yes. Okay, so there's two more examples, but I don't want to make the video too long. So the other two examples will be on the next video and then quiz. Okay, so yeah, that wraps it up for today. Thank you. Bye-bye.